After looking at one-to-one functions in our previous video lecture, we're now going to take a look at inverse functions, and we're going to start with their properties. Our objective is fairly simple: identify inverse functions. Obviously, we have to answer the question, what is an inverse function? But first, let's look at what we already know that's going to be applicable. We know what a one-to-one function is. A one-to-one function is a function that associates each output with exactly one input. Remember, the function piece says each input has exactly one output. So a function that also does this is called one-to-one. Each input has exactly one output, and each output has exactly one input. Okay, if a function is one-to-one, and this is key, I wrote this with I'll put a couple of double line arrows here. If a function is one-to-one, then that function has an inverse. This is really what we're going to focus on a lot in a number of upcoming video lectures. Functions and their inverses, because inverses reverse one another. Inverse functions are undoing function. An inverse function, a function that reverses another function. And I'll include here, it undoes the given function. An inverse function undoes a given function. Okay, inverses undo one another. Think about, if you will, think about inverse operations. The operation addition has an inverse operation, subtraction. The addition operation is undone by its inverse operation, subtraction, and vice versa. Okay, an inverse function goes the other way. So example 1 here kind of gives you a sense of what that looks like. The function is 2x plus 3. So in goes x. I multiply it by 2. Again, following the order of operations. I get 2x. I then add 3, and out comes 2x plus 3. Okay, so if in goes a number, I double it, I add 3 to it, out comes another number that's larger or smaller depending upon positive or negative. The inverse function goes the other way and undoes the original function. So 2x plus 3, I'm going to go now the other way and undo it. So in comes 2x plus 3. I first subtract 3. Out comes 2x. I then divide by 2. And out comes x. Okay, so that's the inverse of things. You're undoing, going the other direction. So the inverse function of 2x plus 3 is x minus 3 divided by 2. Subtract 3, divide by 2. So here's the function. F of x equals 2x plus 3. We noted that right here. Okay. We multiplied by 2, and then we added 3. The inverse function, the one that undoes it, is notated with a little negative 1 just above and to the right of the function's name. So the inverse function of x is x minus 3 divided by 2. We subtract 3 first, we divide by 2 second. So there's the inverse function. And they undo one another. Notice x went in to the x function, out came 2x plus 3. This result went into the inverse function, and out came x. We undid it. We got back to our original starting letter in this case, or value. Some notes about inverse functions. Okay. F negative 1 of x, or the inverse function of x, g negative 1 of x, or the inverse function of g, etc. That little negative 1 after the function's name, notice it's this is the f function, this is the g function. It tells you that this is the inverse function. Okay, that's the notation for it. Now, that little -1, even though it's written it's written up and to the right of the function's name, it is not an exponent. Okay, that confuses a lot of people. Okay, that little -1 just above and to the right of the function's name denotes inverse, not exponent. The inverse function gives us back the original value. So let's look at that example let's look at those two functions we just looked at. We said that f of x equals 2x plus 3, and the inverse function f -1 of x, the inverse of f of x, is equal to x minus 3 divided by 2. And let's put 4 in. Okay, so 4 goes in. I'll come back to this side. 4 goes in. Multiply it by 2, add 3, and here you have it. Multiply by 2, add 3, out came 11. Okay, now we're going to put 11 into the inverse, and we're going to do the opposite of those things. We're going to subtract 3 and divide by 2. So 11 goes in. Come back to here again, you can see it. This came out as 11. We're going to put 11 in this one and go backwards to undo it, to reverse. Okay, so 11 goes in. 11 minus 3 divided by 2. 11 minus 3 divided by 2, out comes 4. So we started with 4. We ran it through a function. We got 11 out. We wanted to get back to 4. So we used the inverse function to get back to 4. That's the only way you can get back to 4 is by using the inverse function. So the functions, the f of the inverse function gives you the value back, and the inverse of the function also gives you the value back. Inverses and functions undo one another, and you get back right where you started. Okay, let's also speak briefly about domain. The domain of the function is equal to the range of the inverse function. And the range of the function is equal to the domain of the inverse function. So the domain of f is the same as the range of the inverse, f's inverse. The range of f is the same as the domain of the inverse of f. Okay, so those are some properties of inverse functions. Let's verify inverse functions and see what this looks like. Okay, so we're going to apply this right here. We should get back to x when we do these two things, because if they're inverses, we'll get back to the original input. Okay, so here we're going to do a couple of, we're going to look at our composite functions, because this is a composite function to verify inverses. Example 3, verify that the inverse of g of x, which is x cubed, is the inverse of g, which is the cube root of x. Does the cube root of x undo x cubed, and does x cubed undo the cube root of x? Let's see. G prime, whoops, that's not what I want. I want g negative 1. Sorry about that. Okay. The inverse of the function, the inverse of the original. Okay, that's the same as the inverse of, well, the original function is x cubed. Okay, and the inverse function says whatever comes in will go right here underneath the cube root. So this is the cube root of x cubed. This piece here is the input into the inverse function. And of course, the cube root of x cubed is x. So we see that the inverse function, the inverse g function of the g function gives us back the x we're looking for. We started with x, we put it into the function, and then we put it into the inverse function, and we got back to x. So these two functions are indeed inverses. Let's verify the other direction, and let's start off with the inverse function. Do the inverse function first. Remember, the inside function goes first. Do the function second, and we should get back and undo. It should undo itself. Okay, so the g function says this goes into the g function. Well, that is this. So this is the cube root of x. Okay, so I replaced the inverse function with what it is. Now I'm going to run this into the g function. The g function says cube what comes in. Okay, cube what comes in. Well, what comes in is this, the cube root of x. Okay, and the cube root of x cubed is also x. So I've just verified that these are inverses of one another. Okay, let's look at number 4, example 4. Let's do the same thing with a second example. Verify that the inverse of the function f of x equals 2x plus 6 is, the inverse function of x is 1/2 x minus 3. And I did this twice. I'm not so sure why I put that little mark there. I want to use the -1. Okay, so let's first replace the inside function, which we're going to do first. The inside function is 2x plus 6. Alrighty, now we want to run the 2x plus 6 into this function. This function says take half of the input and subtract 3. That's what the inverse function says. So the input is 2x plus 6. Okay, that's equal to 1/2 of 2 is x, half of 6 is 3, minus 3, and that gives me x. So that worked in that direction, or with the nesting done, we did the function first and then the inverse second. Now let's do the inverse first and the function itself second. So f of, well, the inverse function is 1/2 x minus 3. And now we want to put this input into the f function. The f function says 2 times x plus 6. Well, here's the input. This is the x coming in, the input. 2 times 1/2 x minus 3. Okay, 2 times 1/2 x is x. 2 times -3 is minus 6, plus 6, and I get x out again. So I've just verified that these are inverses. They undo one another no matter what value I put into the function. Okay, next up we're going to talk about how to find an inverse function both graphically and algebraically.